Hello students, welcome to the course Transport Phenomena. The subject code is CH881. The theory marks is 100 and the sessional marks is 75. So today we are going to discuss the syllabus of this subject. So this syllabus mainly consists of three modules: momentum transfer, heat transfer, and mass transfer. You already know momentum transfer, that is basically fluid mechanics. Secondly, you have also studied the heat transfer, and thirdly, you have studied mass transfer as well. So, in this course, we'll discuss these three transfers in a great detail in a advanced way, or you can say using vector calculus and tensor calculus. Okay. So, firstly, momentum transfer. So in momentum transfer, we will study the molecular transport, basically Newton's law of viscosity, the properties of fluids, how how viscosity changes with pressure and temperature. Next, convective transport. You already know convective transport. Okay, then we'll study cell momentum balance. Basically, cell momentum balance is nothing but balance of momentum in out. Okay, so instead of doing mass balance, we are doing momentum balance. Next, equation of change. So you already know Navier-Stokes equation. Okay, the thing is that we'll study Navier-Stokes equation in 3D. Okay, and in all possible coordinates: cylindrical, rectangular, and spherical as well. Okay, and lastly we'll study some case studies like falling film, pipe flow. What happens if a water film or some organic solvent film is falling, right, over inclined plane? So what will be the velocity profile, the mass flux, etc. Similarly, we'll study the how the fluid dynamics changes if a water is flowing in a pipe, okay, circular pipe, or you can say cylindrical pipe. What is the velocity profile? What is the maximum velocity, average velocity, mass flow rate, everything else, and how it changes with pressure. You also know Hagen-Poiseuille equation, so we'll derive Hagen-Poiseuille equation. So next we have heat transfer. You have also already studied the heat transfer. So first, molecular transport, you know Fourier's first law, right? Then convective transport, you know, that is basically Newton's law of cooling. Again, we'll do cell energy balance here as well. So how to do energy balance, right? And equation of change, basically this is Fourier's law in 3D and in different coordinate systems. And lastly, we'll do case studies like heat conduction through a composite wall, how to solve this problem using equations of change, and heat conduction with source. With source means suppose there's a cylindrical pipe, and at the center we have some source. It is constantly giving energy out. So how to solve those problems using equations of change? So mass transfer. In mass transfer, we'll study molecular transport, that is Fick's law. Again, convective transport and cell mass balance here as well. We'll do basic mass balance or species balance. Then we'll have equation of change. Equation of change will be having uh, the mass transfer equations in 3D in all coordinate systems. And lastly, we'll do case studies like equimolar counter diffusion. You have already came across this, but we'll solve in a more detailed way using 3D equations. Also, diffusion through stagnant film. We have already studied that. So we're going to study this, but in a different perspective. So the prerequisites, what you need to know before starting this course. So basically, you should have an idea about vectors, tensors, and differential operations on vectors and tensors. Okay, you probably you're new to the term tensors, so we have to go through it first. Differential operations, you already know del operator, Laplace operator, those operators, how they operate on vectors and tensors in detail. Integral theorems, surface integral, volume integral, Green's theorem, divergence theorem, all those stuff. And lastly, how to uh, write the equations in cylindrical and spherical coordinates. You already know how to write equations in rectangular coordinates, but apart from that, we'll study other two coordinate system. And the textbooks referred for these courses are as follows. So mainly, I will follow Bird, Stewart, and Lightfoot Transport Phenomena by Willie. It is also available in the library, but uh, I will share the chapter-wise PDF in the Google Classroom. So don't worry, you don't have to download the whole book. Whatever I teach, I will attach the chapter-wise PDF associated with it to you people. Secondly, we have Brodsky, R.S. Hershey, Transport Phenomena. We'll rarely follow this book. And thirdly, Bodra's Introduction to Transport Phenomena, Momentum, Heat, and Mass. So we'll rarely use those two books. I will primarily use the first one. So if you are interested in reading other books, then you can go on. But I will mainly follow the first book. Okay, thank you.